Can hear my voice, just confirm so we can start the new chapter. Okay, thank you very much. Assalamu alaikum. Good evening again after a short break. We continue our lesson on a new chapter. This is some kind of more like examples of problems of some of different protocols. Okay, these are just examples of the problems of some of the protocols in TCP/IP. But before we start talking about this one, so I remove the frames and everything from here from the notes. Before I start, I will go to the board and just review what we need for this chapter from network or from TCP/IP architecture. In TCP/IP architecture, TCP/IP networks or TCP/IP architectures, we have now one layer here, which is network access. Usually we call it 1 and 2, and we have the third layer here, which is IP, and then we have fourth layer here, and usually we call it the seventh layer here. So it's usually it's network access or MAC or physical layer. We call this layer IP layer. This is TCP and UDP layer, that it has two protocols. One is TCP, another one is UDP, and on the top we have application layer. Okay, so this is the model for TCP/IP. Usually we call this layer 1 or 2, 1 and 2. We call this one the third layer, and this one we call it fourth layer, and usually application layer we call it 7 layer. Never we use the other numbers for these layers. In MAC and physical layer, we use MAC addresses or physical addresses, and something that we have in this layer or protocols is like Wi-Fi is that uses the Wi-Fi frame in this layer, Ethernet in this layer, PPPO which is being used in ADSL is this layer, and so far and so forth. For example, optical fiber and DQDB, and those protocols which are related to media and the medium and transmission on telecommunication networks, they are on this layer. But IP also, they have protocols like ICMP and protocols like ARP, and usually services like DHCP works in this layer. Usually we have routing, and here talk about packets which they have source IP and destination IP. Source IP addresses and destination IP addresses. Okay, this is the IP layer. And in the upper layer TCP and UDP, something which is important first is that which protocol we use, either is TCP or there is UDP, and then when we know what protocol we use is the port number. What is the port number? 0265,000, around 65,000 port number, which shows the process number on the IP. Okay, a specific IP, we have the port number. We already discussed it in firewall, which process its port number, which process for the source and which process for the destination. So it's like, for example, TCP or TCP or UDP, and then source port and destination port. Okay, this is what is it? Let me first see what Mohammed says. Okay, this one. And then these are the things that we need to know about the layers. Just review, and then the application layer, and then I see what Mohammed said. Okay, and these are, I separated, and the application layer is the process and application which executes the application, and maybe for example Telegram and WhatsApp, Chrome, Firefox, and Skype, and so on and so forth. These are the things that happens in the application layer. So Mohammed says that this article is one of the basic of the networks possible to talk about something. And layers of the networks. Muhammad, you see, something that I explained here is something that we need about the before it's a review. If you say about the TCP/IP, we need to discuss the attacks. Okay, I don't want to talk about TCP/IP because when I talk about the attacks, the students start to ask about the basics, and then I have to go back and explain the very basic things, not even the TCP/IP layers. Okay, now before I want to talk about the chapter or this chapter, I had to review the layers of TCP/IP. Anyhow, if it was easy for you, I can pass this chapter quickly because it's just very easy, and there are small things that we need to discuss. I hope that you understand it well, and if you understand it well and quick, we can finish this chapter only in this class in, I don't know, 20 minutes, 30 minutes. If it's okay for you, we can quickly pass it through it, but I hope that you understand the chapters and everything that we discussed. Yes, they are easy. These are easy things. Okay, I will go to the chapters and then I start. You see the security, it's the first thing we want to discuss. Is, as Mohammed says, these are easy. Scanning is a tool for managers to scan for the configuration of the network, and also we can use the scanning as a tool for know the potential target. Okay, and requires the detailed knowledge about the protocol to build. For making the scanner, there are several steps. It's easy, but the first thing is that, for example, if you have one network which is connected to one switch, okay, for example, this is a network, and the computer which are connected to one switch, and maybe you also have these are the computers. Okay, maybe you also have one router in the network that connects you to the internet. Okay, one router, and through that router, for example, you connect to the internet. If this is your computer, okay, if this is your computer, when you connect to one network, you usually have one IP address. For example, your IP address can be 192.168.0, for example, 7 or 17, and with the subnet of 255.255.255.0. okay, and usually the gateway for you is, for example, 192.168.0.1. These are the basic information that exists on your subnet mask. This is IP address, and this is subnet mask, and this is gateway. These are the basic information that you can find on your network. Even now you can go to CMD, okay, you can go to your CMD on your computer and you type ipconfig, or if you are using Linux, or you are using Solaris operating system or any other operating system, like except for Microsoft, you can use, for example, something like ifconfig, okay, to get the same information. Even if you want to use Cisco routers, okay, or firewalls, you can use ifconfig. So it's either ipconfig or ifconfig. When you use this command, you can get your own IP address. And when you get your own IP address, using the IP address and subnet, you can understand what is your range, or what is your, we call it همسایگی. Okay, at Jairan, I think in Arabic. Okay, in Arabic you can find your neighbors. Okay, you can find your همسایگی. So based on your subnet and based on your IP address, I understand that the range that exists in my neighbors or in همسایگی of me, or which or the computer that they are my neighbors, can be from .1 to for example 254, or we can say 2, for example 55, which is broadcast, so it's .1 to 54. Something that you can do is that we say for a full, for example, IP address from, okay, to, okay, and you will use these IP addresses here. For example, for IP address from 192.168.0.1 to, for example, 192.168.0.254. okay, so it's for IP addresses from this one to this one. Something that you do is that you can write a code like this. You can write a code like this: ping IP address. So this code that I already wrote for you, this is one simple scan code, okay, and then you will get the results. And for example, get you can get the results and process the results. It's either when you scan the range in the networks, it's either the answer is either, okay, reply or timeout. Okay, when the answer is reply for some of the IP address, it means that you have live node in the network. So it's this simple code that I wrote is a very easy, or one of the easiest examples of scanning for the networks. Okay, and when, for example, you understand after you running this code or typing this code and running in the system, something that you get out of this code is, for example, that the computers, like, I will put some computer, for example, computer like 192 and 168.0.172. Okay, for example, you get reply from this computer, sends reply. Okay, if this computer sends reply, again you can write another code. So you say for IP address one 192.168.0.172. okay, for ports from 0 to this number, for example, for ports from 0 to 65,000. Okay, 655,353, and send the packet to this port for both TCP and UDP packets. Okay, you send the information to these ports, these ports. Actually, we send information to these ports, and then it's, again, let me close the block. You can write it either in C or, I don't know, C# or whatever it is. Okay, you send the packet to these ports, and again from the you will get the result. Same thing here, you get the result, and from the results, if you receive reply, okay, or nothing, or whatever you receive, reply or nothing, or whatever you receive, then you will decide what is the next step. So the first thing for understanding the network or know the network configuration is scanning. That, for example, which ports are open, which applications are running, and what are the ports or IP addresses that have been blocked by the firewall. So the first thing that we want to discuss after scanning, so we know what is a scanning. Okay, we know what is a scanning, and we can scan for IP addresses, and we can scan for port. The main reason for scanning to get the yes, Saleh, concatenation. We should first scan for the IP addresses, and then we scan for the ports. Okay, and after we get the information about the scanning, the next thing is usually we scan to get the configuration. So we scan the network نه اومده فحص شبکه. Okay, to get the configuration. Okay, للحصول على التكوين. Okay, للحصول على التكوين, and we do either for IP addresses or we can do it for the ports. Okay, as the codes that I already explained to you. And then if I go back to the previous slides, we discussed the TCP/IP. I'll go to whiteboard 81. You see, one of the protocols that we use in IP layer, one of the protocol after scanning that we can scan with ping. Okay, with ping, that ping uses ICMP protocols. Okay, ping uses ICMP protocol, and ICMP protocol is in IP layer. Okay, another application of ping is in addition to the test, and whether we know that we can check whether one computer is live or is on or shut down or it's not alive, are two property of the ICMP that we can use to attack the nodes. Okay, the thing is that, for example, when we have a computer like A that sends the information to R1 and send the information to R2 and send the information to R3 and send the information to R4 and then R5 and then, for example, B. Okay, consider that this is your network. Okay, and the A wants to send the information to B. We have something or one concept congestion control التحكم في الازدحام. Okay, we have the concept of congestion control التحكم في الازدحام, that when the traffic in R4, for example, is we have congestion or we have ازدحام. Okay, it can when it receives the package, for example, from A that should go to B. Okay, it will tells the A. Okay, the R4 can tells the A to please slow down by, okay, something like that. We call this node this type of packets that we use ICMP protocol. Okay, and we use and we call it source quench message. Okay, we call it source quench message. Quench in Arabic يطفأ. Okay, يطفئ message. So R4 can tell A to something like that, please slow down by something. Okay, and it will, the A and the B and C or whatever are the computers on the networks, they will slow down the transmission, and then the information that will go through the router R4 will be decreased. Okay, was it clear? This is the protocol, and this is the use of source quench, and this is the ICMP, and this is in IP layer. Okay, now you see something that you can do as an attacker. If you are an attacker, okay, you are here. Okay, it is not important where you are. Okay, for example, you are attacker. First, you can forge R4 IP address. Okay, and then you can send fake message to A. Okay, you can force R4 or one of the router IP addresses and you can send fake source quench messages using ICMP protocol to A. Okay, something like this. Let me change the arrow color. Okay, as an attacker, you can send the information to A and tell it, please slow down to 0. Okay, yeah, one by one. For example, when you say first you tell A, okay, decrease the rate to 50, and then you say please decrease the rate to 20, and then decrease the rate to 10, decrease the rate to 1, and decrease the rate to 0. A will stop sending information. Okay, A will stop sending the information, and it's like similar to what type of attack? What happens to A? What type of attack is that? No, it's not a scanning, it's not a SALA. I'm typing something different. When you make A not to sending the information, what happens to A? What happens? No, yes, it's like disconnect. So what type of attack is that? No, not the name I'm expecting. I'm searching for. It's DOS. Okay, because it's denial of service. You do not let A to yes, it's correct, you disconnect A, but you do not let A to receive the service. Okay, and it's type of DOS. It's one of the types of DOS attack using ICMP source quench. Okay, another way of using the was it clear, source quench? We will go to the next one. Okay, if you want, just print a screen. Yes, denial of service, print a screen from this attack. I want to delete the attack and make another attack. Okay, so you see, we also have, again, I don't want to talk about the attacker. I will take attacker out of picture. Okay, I want to talk about the protocols. There is another way, that something that happens again for is the home. Okay, again for congestion. Okay, if there is something wrong with the network traffic on R4, for example, maybe we have R7 here. Okay, that you can also have the I don't know, network similar to this one, and then for example R8. Okay, maybe your network is like this. Okay, maybe your network is like this, and then when you send the information to R7, again when in R to R4, sorry, and again when in R4 you have as the home, Okay, R4 can send the information to the senders or to the routers beside or before. Yes, when it's shuluk, exactly. It can send the information to R3 or it can send the information to A. Okay, and request when just remove this one, and it can send the information either to A or to R3. We call this kind of request ICMP. It says please. Okay, no, Muhammad, right now it is the normal protocol, it's not attack. Okay, it says please, for example, R4 says please redirect your crowds packets to, or please use the next route. Okay, so R4 can send message like this: please redirect your packets to, or please use the next router. R4 will send this information either to A, okay, or send this information either to A or R3, okay, and then they will send the packets to R7, okay, maybe like this, and they change the route. So the problem with the izdiham or the problem with shuluqi or the problem with the crowd will be solved. Okay, so this is the protocol. This is what we can do. It called ICMP redirect message. Okay, this is ICMP redirect message. So this is it. This is something that normal happens in the network, that you redirect the messages from one user or one router to another router. Something that your attacker can do is that, again, the first thing is forge router IP address, and then it sends fake redirect messages. Okay, so for example, if attacker call itself R999, okay, if it call itself R999, it will send the information to the, let me remove this one so it's be easy. It will send the information to A. Okay, it says, okay, I am R4 and please, I'm busy, I'm shuluk, and please redirect your traffic to R999. Okay, this is the forward message. It says that attacker says I'm R4 and please redirect your traffic to R999. So the A will send the information to attacker. So from now on, it depends on the behavior of the attacker, or it depends on the behavior of you. What do you want to do with the information? The first attack that you can do is DOS. Send the information away, okay, drop all the packets, and you will disconnect the A. So it's the first thing that you can do. It's DOS. What is the second thing that you can do? What is the second attack that you can do? You tell me. Send fake information to B. Not fake information. What else? What else? Other students. That's the first thing. Yes, we can disconnect A, which is DOS attack. No. What other attacks? We already discussed it in the previous class. No. You see, if attacker, because already attacker told A to send all of the information to me, okay, and it can forward the information of A to R4, and therefore the information will go to B and then come back to R4, and it will send to attacker and go to A. So everything is as previous as before from the B point of view and A point of view. What type of attack is this one? Yes, exactly. Yeah, this is MITM. Okay, this you can either do DOS, okay, not DDoS. DDoS is something more complicated and it's different. You can either do DOS attack or you can do MITM using the redirect. Okay, yes, exactly. MITM and DOS attack. You can do the DOS attack and MITM. Okay, let's go to the slides to see what happens. What are the other things that we should discuss it? Other concerns, okay, not security. So the first thing that we discussed was what is scanning, what we scan for, and what are the tools for scanning, okay? And then we discussed about ICMP, which layer of TCP/IP we use ICMP and what it is used for. It's necessary for test in the network, but also can be abused or can be used for attacking the network or just scanning the network. One of the ICMP messages that we can use or abuse for attack nodes is ICMP source quench. Again, it depends on the node whether it replies or not, okay? Let me write it in Arabic. It depends on node whether it replies or not. وكذلك يعتمد على العقدة سواء استجابة أم لا. Okay, this one, you just take this one and it depends on the operating system and the version. ذلك على نظام التشغيل والإصدار. Okay, it depends on OS and protocol version. Okay, it depends whether they, for example, reply to source quench or no. Maybe, for example, Windows 10 does not reply to source quench or does not listen to source quench, but maybe Windows 10 or Windows XP answers to source quench. It depends on the version of the protocol and then version of the operating system. Anyhow, these are the attacks that you can use, examples of attacks that you can arrange using ICMP. So the next thing is TCP, and this is TCP simplified. Okay, the way that TCP, we want to talk about the attacks on TCP, and this is the way that TCP works. Before we explain the attack, we're going to talk about the TCP. Again, I should go to the same slides. I think it was 81. I should go to board. You see 81. Yes, it's 81. Yes, the TCP is here. TCP is here, and then TCP is connection oriented. It's like telephone. Okay, in connection oriented communication, we have 3 different marhale. Okay, yes, like hotef. Thank you very much. It has 3 different levels. So the first level, or aval, is connect. Okay, the second level is transfer. Okay, the third level is disconnect. Okay, always connection oriented communications use these 3 steps, or these 3 levels, before they do anything. Okay, so they connect, they transfer information, and then disconnect. So in TCP there are some flags. We say flag, or we call them flags, or there are one flags that they are bits, single bit, that it can be 0 and 1 for example starting the conversation or connecting, for disconnecting, and also for checking the connection whether it's connected or not. Some of these flags are SYM flag. It can be 0 and 1. Okay, or for example reset flag, that's synchronization. Okay, reset flag, or RST, it can also be 0 and 1, or acknowledgement flag, or acknowledge, that it also can be 0 and 1. So we use these type of flags to communicate in TCP, okay, or to make connection in TCP. For example, let me remove this part. For example, if using TCP, if I want to talk with B, and this is the timeline. Okay, yes, exactly, Muhammad. They use the encrypted communication. Yes, exactly. So if this is A, okay, and then A, for example, wants to connect to B, it says, okay, for example, like I want to connect to you, it's more like hello. Okay, and it sends, for example, sin equal to 1. Okay, and then for example it says I accept your connection, okay, with for example ACK is equal to 1. Okay, and then for example it's more like goodbye, ma salam. Okay, and then for example it says RST is 1. Okay, and sometimes B doesn't answer, or usually it answers okay, or sometimes it says okay, finished, communication finished. Okay, something like that. These are the things that we have in protocol, and in protocols, and it depends on the protocols. So we will go, this is the concept of how TCP works. It's connection oriented, and these are the way of connection. But the more details, we don't need more details about the TCP because these are the examples of the attacks that you can do on the protocols, okay, or attacks that you can arrange for the protocols. Rasha, these were the things that I explained. Consider that thing here, not always, because during the protocol it means different, okay, but here, for example, sync can be hello, okay, act means I'm listening, okay, or I have you, reset, it's something like bye. Okay, it's just simplified of the protocol because they have different applications, okay, just only for this type of beginning of the protocol and end of the one, beginning of the one communication and end of one communication, we use this one. Consider the sync, acknowledge and reset, something like this, okay. Now we say that when one client want to communicate with server, for example, when you click www.yahoo.com, okay, or when you want to log in one page, okay, when you want to log in one page, or for example, when you go to one web server, it's like that. You say, okay, you send information, okay, I want to connect with the server, and then the server will reply, okay, you can connect to me, and then you start sending the information. This is like this. And we have SYN flood attack. This is the first attack for TCP. I'll type it here first, TCP based attack. First TCP based attack is SYN flood, okay, something that you do, you start sending information to the server, and it's like call, okay, in HOTF, okay, you start call, when server peaks, you keep the server on hold and make another call to the server until the buffer of the server is full. So it's like that. Just read it, okay, and if you have problem with that, you can ask your friends to translate it to Arabic, but it's easy. You see, you start sending TCP requests to the server, and then when it confirms that okay, you can make a connection, or when it opens one port or assigns one port for you and assign the memory and everything, you never continue on that one. So when you miss this one, you start a call, it says, it confirms that okay, you can connect, and then you miss this one, you can make the server busy and full the buffers. Okay, was it clear? Yeah, sir. Okay, so yes, it's very easy. It's like that you have many telephone lines, and you start calling somebody. When he picks up the phone, okay, you keep him, okay, please wait for a second, and then you take another telephone and call it again until you make all of the telephone lines busy, and you keep them busy. We call this attack SYN flood, okay. And the next, but it says that it's easy to prevent SYN flood because in today's systems they use some other methods instead of the sync. For example, they use cookies on the system to keep the information, and no need to keep something in the buffer for the system, and so on and so forth. So in today's networks, it's a little bit difficult to attack, for example, one web server, or I don't know, one a mail server using the Simplot. Another attack I already discussed it with you, because I knew it's going to be here. It's coming. It's the problem with the DNS. Okay, something that I explained for you in the previous class. The DNS security, DNS is the vital service for the internet. Okay, and because we cannot remember all the IP addresses, we use names, and it's type of a distributed database. Okay, DNS is type of one of the distributed database, and it's based on cache or caching system. Okay, you use the cache to work efficiently. For example, if you ask information from this server and it does not have the information, it goes to the next level DNS, and when it receives the reply, it also keep it here, and then you always use this DNS because it's near to you, and it replies with less delay. So it's like that. If you are successful in changing cache of one of the DNSs, you can poisoning this DNS, and then it will goes back, or it will propagate back to this DNS, and then for this computer you can just fool the computer to go, instead of Yahoo or Facebook or Google, it goes to website. But for sure, as your friend mentioned, if you use HTTPS, okay, and if you check certificate of the websites, and if you remember, we talked about KDC and CA. If you use KDC and CA, and you remember, if you remember those things, you click on the lock on the website, you can understand that this is real or fake website. So for HTTP and for HTTPS for sure, for HTTPS you can prevent still DNS attacks possible, but if it redirects you to the wrong site, with HTTPS you can realize or recognize whether this is the real website or this is the fake website. So if attacker compromise DNS database, I already explained this one for you. This is also possible through the networks, and also can affect other DNSs that they are updated based on this DNS. We call this one cache poisoning. Tasneem, I think in Arabic it was something about Sam, if I remember, cache poisoning for DNS. The new DNS is they make sure that usually they won't allow external manipulation of the cache. Usually they don't allow to access the cache from outside, but it's a bit harder, but it's still possible. And also this was it. This was DNS, and then the next one is scanning. What we scan for, we can just go through it quickly, and then we can stop here, because we already had 2 classes and it's already 1 hour for the second class, but we can stop here. But let me just go through the first slide. What we scan for, because I already discussed this one, we scan for firewall configurations, we scan for open ports, we scan for RPC services, remote procedure calls, we scan for non-vulnerabilities, and we scan for operating system details. These are important. These features are important for the attackers to arrange the attacks. Okay, when we want to attack a system, first we need to know this. Okay, and the scan tools and scan methods, they will give us the information of the system that we want to attack. What are the firewall configurations, what are the open ports, if it's possible to run RPC on the computers or on the remote systems, we will know. We will realize what are the vulnerabilities, and then which operating systems they use, or what are the operating systems that they use on the systems. And from here we will talk about the scanners and open and close ports that we can just teach all together in the next class. But before we finish the class, okay, this is up to here, then we write it that in this session also up to slide 12. Okay, up to slide 12. But before I finish, I wanted to talk to you because I finished my class today earlier, just in the second class, to talk about the exam, because everybody is talking about the exam and they are concerned about the exam. I already told Ali, okay, and again I will tell everybody about the exam when we finish the class. Maybe next week or the week after next week. I think it's our last session. Okay, when we finish the class, 15 it's closed and 23 it's how many classes left? Because 15 is closed, it's holiday. We have 8. Today is 2, we have 8, 1 session, I think. 1 session, yeah. It's because 15 is already public holiday. And then 23 is your exam, right? 15 is public holiday, so we only have 8, right? 15 is public holiday, we only for you we only have 8, because I was thinking that maybe we also have 15. In the last session, okay, in the last class, if only 1 class left, it's something I wanted to tell you. In the last class, I will review the whole course. Something I will do if the 8 is your last class, just remind me at the beginning of the class. I will do that. Okay, I will stop teaching, and then I will review the whole course, and I will talk about sample exam questions. Okay, what I am going to ask from you. Okay, and I will review the course. I will tell you what I'm going to ask you in the exam, what are important parts, and what are the questions like, okay, and everything about the questions and the answer and the way that you should answer the questions. And this is the most help that I can do to you. And exam is not that complicated, but you should promise me that at least for those questions and for those answers you try your best, that you learn the subject and answer those questions, and whatever happens after the exam is up to you. Okay? And the exam won't be that hard. Okay, the exam is easy. Don't worry about the exam. But after exam, please do not ask and beg for marks. Okay, whatever you do, it's up to you. I just try to teach you. I try to explain it for you. I try to give you easy exam. I try to give you simple questions, easy questions. But the rest, whatever happens after the exam, please, it's up to you. Okay? Inshallah. Inshallah, all of you receive a good mark. Okay, so this is it also about the exam. I didn't know that 15th is I thought we have another 3 classes, but we already have 1 class. I try in the next class, I quickly, because nothing left in this chapter, I try to finish this chapter, we review, and then we close. Okay, any question? Okay, thank you very. If you have any question, I will wait here. We still have another 10-15 minutes. I will wait and answer. If no question, you can go. It's up to you. And inshallah, see you in the next class. All the best. مع السلام. Okay, and take care.